medians, and the specific name for it is the centroid. So at a centroid, you can actually balance a triangle using just a pencil. And that balance point again is called a centroid. Let's read this paragraph to the left. A triangle will balance at a particular point. This point is the intersection of the medians of the triangle. A median of a triangle is a segment from a vertex to the midpoint of the opposite side. So, for example, here's a vertex, here's a vertex, and here's a vertex. The median is the segment that goes from the vertex down to the midpoint. So this point here would be the midpoint of this segment. If we call this triangle A, B, C, then from vertex A going down to the midpoint of BC would be the median of a triangle. Let's call this midpoint M. So point M is the midpoint of BC, so segment AM is the median of the triangle. If we would call this midpoint F, then segment BF would be the median of the triangle as well. And if we call this midpoint S, then segment CS is also a median of the triangle. The three medians of a triangle are concurrent. Now remember from earlier sections and videos, we learned that concurrent means intersecting. So these three medians intersect at a point, and that point of intersection or concurrency is called the centroid. So this point right in the middle is called centroid. Now, these segments have certain characteristics. If we look at this diagram here, point P is obviously the centroid. Now, you see these congruency marks, they're there because these medians divided the segment into two equal parts, because D is a midpoint, so DB is congruent to DA. F is a midpoint, so AF is congruent to FC, and E is a midpoint, so BE is congruent to EC. Now there's a theorem called the concurrency of medians of a triangle. The medians of a triangle intersect at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. The medians of triangle ABC meet at P, and so let's analyze that for a moment before I go over the formulas. Let's look at median AE. AE is cut into two parts. There's segment AP and segment PE. These two parts have a special relationship. The length of AP is 2/3 the length of AE. So the whole thing, AE, would represent the whole, and the part AP is 2/3 of the whole thing. BP is 2/3 of BF, so BP this piece here, is 2/3 the length of the whole thing, BF. And CP is 2/3 of CD. So CP, right here, is 2/3 the length of the whole thing, CD. So let's put that into practice and see what that means. Let's say the length of AE was, let's say AE is 10 units. So AE is 10 units long. And we want to find the length of AP. Well, the whole thing is 10. We're looking for the piece AP. Now, AP is 2/3 of AE. So AP is 2/3 of AE. Well, we know AE is 10. So AP is 2/3 of 10. That is equal to 2 times 10 is 20 divided by 3. When you multiply a whole number with a fraction, it's like putting the whole number over 1, and you just multiply the fractions. 2 times 10 and 3 times 1. 20 divided by 3, if you put it in the calculator, you should get 6 with a remainder of 2, which is 6 2/3, or 6.6. So AP is 6.6. So since we know the whole thing is 10, you would have to multiply 10 by 2/3 to get just AP. Now let's do some more practice with that. In triangle RST, Q is the centroid. Okay, so we have our centroid. And SQ is 8. Find QW and SW. So the whole thing, we don't know what it is. We know the part SQ. Well, that longer part is always 2/3 the length of the whole thing. So SQ is 2/3 of SW. We know what SQ is. It's 8. We want to find SW. Now, SW is the missing length. The way you get rid of a fraction is by multiplying both sides by the reciprocal. So we're going to multiply both sides by 3/2. That's the only way we'll get rid of this fraction. So now we have SW equal to, we can put this whole number over 1. 8 times 3 is 24/2. And 24/2 is just 12. So SW is 12. Awesome, we got SW. Now we need to find QW. Well, the whole thing's 12. And this piece SQ is 8. So what's left? That's right. SW is equal to SQ plus QW. SW is 12. SQ is 8. So what's left is obviously 12 minus 8, 4. So QW is 4. All right, moving on. Here we have it on a coordinate grid. It says the vertices of triangle FGH are F2, 5. So let's graph that right away. 2, 1, 2, 3, 4, 5. This is F, which is 2, 5. G, which is 4, 9. 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. And 6, 1. 1, 2, 3, 4, 5, 6. Okay. Now let's connect the sides of that triangle. You can be graphing this triangle in your own notes as well for extra practice. Okay, so now we have our triangle. And it's asking us, the question asks, which ordered pair gives the coordinates of the centroid? Remember, a centroid is where all the medians intersect. The median is the segment that goes from the vertex to the midpoint. So we're going to kind of estimate that could be the midpoint. Then we draw another segment to the midpoint, and we draw another one. Oops. Let's say the midpoint's right here. We need a segment that goes from the vertex. Oh, Lord. Let's use a straight line. There we go. So, all the medians intersected at this point. That could be considered the centroid. Now let's count to see where that is. 1, 2, 3, 4. So the x-coordinate is 4. 1, 2, 3, 4, 5. So the centroid is at 4, 5. So our answer is B. Okay, let's do some guided practice. There are 3 paths through a triangular park. Each path goes from the midpoint of one edge to the opposite corner. The paths meet at point P. So we have 3 questions here. They want us to find the lengths of some of these segments. So these points here are the midpoints. All 3 medians meet at point P, so P is the centroid. They tell us SC is 2,100 feet, or 2,100. Find PS and PC. Well, PC is the longer part of the segment, so PC is 2/3 the whole thing. The whole thing is 2,100 feet. So PC is 2/3 of 2,100. So we'll just plug that right in. If you put that in the calculator, you can put it as 2,100 times 2 divided by 3, 1,400. So, and what I did in the calculator was 2,100 times 2 and then divided by 3. And that gave us 1,400. Okay, so this piece right here this piece right here, PC, is 1,400. Just want to make it clear for you to see. So now they're asking us for P as this little piece that's left. Well, we know the whole thing's 2,100. This whole segment here is 2,100 or 2,100. This larger piece is 1,400, so what's left? We have to do 2,100 minus 1,400, and that gives us 700. So this smaller piece here is